So Xen provides us with a plethora of shell-based tools, at least 3, which is considered a plethora considering that usually applications provide merely 1 or 2 front ends for management. However, in addition to the shell, sometimes it might be a bit more comfortable to be able to manage your Xen instances via GUI. So let's just have a quick look at GUI management using Virt Manager. So Virt Manager is included with Linux builds. We're using Ubuntu, so we'll search for it in the Ubuntu package stack, which implies, of course, it's available for Debian and should also be available for the other distributions, such as Xenos, Red Hat, SUSE, etc. So this gives us GUI management of Xen instances, which are basically DOM-Us or guests. It also provides us with console access, basically VNC to DOM-Us. So through the GUI, we can invoke console access on demand as needed. So it's a way of consolidating access to these various nodes. It also allows us to provision. So provisioning of DOM-Us as needed. So you can do quite a bit of your administration from this simple front-end tool. And certainly it allows us to influence the state of the DOM-Us, so state changes or manipulation. So for example, on and off, restart, pause, unpause are examples of state change capabilities. Now it requires XenD HTTP access, or optionally secure access via TCP, and usually that default port is 8000. So for your firewalls, be sure that TCP 8000 is available. That means XenD, wherever your Xen instances, Xen servers are, be prepared to update the config to allow access into TCP 8000. So let's have a look at rolling this out. We'll install Virt Manager on Xen server, Linux CBT, Ubu VM1. Since it's Ubuntu, that's simply going to be an aptitude install, and we'll just have it enter yes for any prompts. Virt Manager. Before doing so, of course, we'll search for the packages that are available. So let's copy this into the buffer and have a look over on the remote side. Aptitude search, Virt Manager, and this will come back momentarily with the desktop application. So again, it's just a graphical front end for effecting these changes, but it's useless, of course, without the appropriate socket communications on the back end. So let's paste that in, and that'll get us Virt Manager momentarily. Now, again, our server doesn't have the X stack or Xorg stack or a GUI stack, so that means we'll be exporting Virt Manager back to our local system. So let's just note that Xen server need not have Xorg stack. Simply send X output to local system, whatever your local system happens to be, let's say an Ubuntu system. And again, this is going to build a stack for us, the prerequisites, and get Virt Manager going momentarily. And when you do an SSHX, so as we've done before, so use SSH with the X option to redirect X session information or X data to local system. Just use that X option, the uppercase X option, when connecting, and that'll automatically create, should automatically create on the target system the appropriate X authority file, which facilitates the redirection of X traffic. So let's see what's happening here. It seems to be installed. Let's do an aptitude search again. It should show an I, and that's correct, so it's now installed. If you type Virt Manager, for example, there are a number of tools, not just Virt Manager, but the ability to clone, etc. So Virt Manager, this will attempt to kick back to our local system, giving us a GUI. So it's not able to connect to libvirt, not able to connect to the remote system's port 8000. So it tells us to verify that Xen host kernel was booted, meaning that we are in Xen mode, which of course the DOM stat can tell us, or just Xen info, and that the Xen service has been started. Well, we know both are true, so if we psef grep, for example, Xen, we know it's running. And XenInfo gives us details. So it's certainly running. But as mentioned, the config is yet to be updated. So this is a simple interface. We're not able to connect without it. And also this interface can be used to connect, let's say, to other nodes that have Xen. So the hypervisor Xen, it's not limited to Xen, but of course KVM is included. Xen, specify remote system. You can use TCP, SSH, SSL, authenticate, and then connect to the remote system. So we're going to kill this temporarily until we set matters up. So the next step for us is to update the configuration. So update XenD configuration. Everything's beneath, of course, etc Xen, and the main config file, which we briefly looked at, is xendconfig.sxp. So this needs to be updated. And what are the directives that are important? Well, one is the XenD HTTP server. We need to turn it on, ensure that it's enabled, and the port with which XenD HTTP server listens should be XenD port, and we'll just default to 8000. You can make it whatever suits your environment security-wise. So from ubuvm1, let's navigate into etc Xen, where we'll modify our config file xendconfig sxp. And let's search a document. A number of directives are here, including but not limited to SSL related directives. But let's search this for HTTP. And this should bring us to the area where it's defined. So we'll just include a comment that's indicative of our footprint, cutting and pasting these two directives, changing one to yes, and uncommenting it. Then let's also search for Xend port, and that should be here. So let's also include a comment so it's easy for us to find where we've made changes, cutting and pasting, uncommenting, and that should be set. Again, a number of other settings, SSL, 8003, it's a different port, which key file to use, etc. You can have it point to, if your systems share certificates, those certificate files for authentication, for SSL authentication. Now, of course, this will require the restart of Xen. How does it impact our DOMs? Well, XMList shows that they're currently both available. And XM, let's say DOM state 1515, well, it's currently idle, but it is accessible. It sends some packets to it to be sure that it responds accordingly, 50. So it's up. But we do need to restart, because if we netstat ntlp grep, let's say 8000, a simple change of the config doesn't affect the access. So virtman will not be able to connect. So let's say virt and see what comes up. Still not able to connect. So we have to restart the service. So let's go ahead and just note we're going to be doing an etc init. It's going to be a XenD restart, update config, restart XenD, and retry virt manager communications. So that's going to be etc init XenD restart, followed by a rerun of virt manager, and that should help us out a bit. So let's restart this, and I'll restart the Xen daemons. Now, how does it again impact our current DOMs? Notice still 15 is the DOM ID for Ubuntu guest 1, and let's try to ping it to be sure it still responds. No problems there. And of course, we can try to connect to it. It should still come up. That should not be an issue. So that DOM-U is still there. We need not provision additional DOM-Us at this particular point. We just want to make sure that we're able to manage the DOMs. And then, of course, you can clone, copy, provision, tie to additional storage, so on and so forth. So with that said, let's do a netstat to see what we've got. There's 8000. It shows us Python. We've mentioned Xen is written in Python. So restart, netstat ntl grep, let's say 8000 should reflect the process. And now let's relaunch virtman with just exclamation virt. Now it shows, and it's a simple interface, nothing fancy of course, but it gives us just the information we need. So it shows a running graph of the usage, CPU usage associated with the node. You can sort by the various names, no big deal there. DOM0, Ubuntu guest 1, double click, you get the console, and you'll be able to interact with it accordingly. And it's VNC enabled, so of course you'll need to enter it to be able to make changes. Let's stretch this out a bit and press enter. That gives you access just like you would. So it's basically a pass-through to call VNC viewer to give you access to the remote system, if config, so on and so forth. Looking good. can update the configuration, change the IP, it should respond. In fact, since we're on the console, let's go ahead and do that. So we'll modify ad hoc etc network interfaces. And it's DHCP currently. As we've mentioned, you can treat these interfaces as you would any other. So just change it from, let's say, DHCP to static and start assigning addresses. So maybe 192.168.75. The primary system's 105. 106 should be free. We could always confirm it, maybe apply that IP, or maybe we index it 10 above, maybe 115, or maybe 100 above, which will put us at 205. Either or, we determine where we want to write it, and the breakout of this we'll just use appropriate sequence, Control-Alt, and let's just see that the ports, the IP address is available, send some packets over to maybe 75. Since we're at 105, let's just go up that by 50 and make it 155. So nothing's there. It looks like it's good. So we should be able to go back to the console and make that change, giving it 155. Of course, you'll do your IP address planning ahead of time. Let's set the net mask to 24 bits and the gateway accordingly to .1 so I can get out if necessary in DNS name servers to the two that are on the wire for us, 101 and 102, the consistent nodes. And that should be fine. That'll give us access outbound once we restart networking. So of course it's going to involve invoke networking restart. And because we're on the console, we'll still have access. We won't lose access as if we're connected to the console. Now it shows that it's 155, as you can see. Now let's send some packets again. And we should be able to just bring this up from the history. So that still sends packets outbound. And then from our local system, or one of these systems, we should be able to send some packets over again. So let's send some packets 155, and now it comes up. So it's now 155, but what about the old address, 50? That address is no longer functioning. Let's go back in so we can change the IP, no problem, manage it through the console, so on and so forth. You get information, show virtual hardware details, this GUIs, if you will, the hardware associated with the node. Simply reads the config file. Every node, every object has an UUID. Performance, key metrics, CPU, memory, disk, network, currently load utilization, and shows 8 gigs of which an eighth or 12.5% are assigned. Number of processors, you can change these, but of course they don't take effect until you restart the node because the CPUs aren't dynamically assigned. Whether or not you pin a particular node to a particular CPU, that's possible if you want to control carefully the resource allocation. And these are just, again, settings being read from the config file at etc.xen that pertains to the host. The boot device order, the only one checked is hard disk. These are the other ones we've mentioned: N, floppy, CD-ROM, D, etc., hard disk C. The basic disk is served from the dev tree as an LVM volume, which is partitioned accordingly. The CD-ROM's the ISO image. This is the NIC, and it's using the hypervisor mode default. You can specify a driver such as a common E1000 or otherwise. The mouse, PS2, VNC is the display, 5900 is automatically assigned. Key map, auto, but you can specify the language if necessary. So this again is just read directly from the config file. Add hardware, this should be reminiscent of VMware, so if there are other things that the node should have, then you can specify as such, maybe another network card, which you then need to create a bridge for, which we've yet to do. We currently have one defined. So you can get information about the node, you can go back to the console and do various things according to whatever is necessary. So of course this is grayed out because it's on. You can pause the node, certainly. That's your state management. Now it's unresponsive, and of course from the shell on another side, if you try to send some packets to 155, it's paused. Go back, unpause it. So pause, unpause. Go back to this node here. We should be able to send some packets in, and that comes back accordingly. You can shut the node down. This will kill it altogether. You'll see the console reflect it. It sends the appropriate signal, which is an init 0, which kills the services accordingly. Now, certainly at this stage, the node is no longer accessible, but of course always test in the event that it's an aberration or an illusion or so on. Fire it back up with play. The guest will come back up. Resources will be subtracted from DOM 0 as expected, and so on. You even have the option here to clone. So this is a great way of creating a node that's just like this. So you cannot share, of course, the storage that's associated with the primary MAC address associated, and you can specify where it should get its disk, where it should store it. You got to give it storage, and you can clone it through that interface. Rather straightforward. You can migrate it from one Xen server to another Xen server. As we've mentioned, there's the live migration support with Xen. Take a screenshot, save it to a file, perhaps if you want to show someone for troubleshooting purposes, etc. Resize the VM, scale, that's just of course viewing full screen. You can send these keystrokes once a node's up. These are the various TTYs that are available, which makes it a little bit easier than the standard VNC, although you can do it with VNC, no problems there. It's just that this just makes it a little bit easier to send those keystrokes. So for example, if you're in X, these are common strokes. Control-Alt-Backspace certainly to restart X, or if you want to reboot, Control-Alt-Delete, or just to access a different console than the default TTY 0 upon which we're normally pinned. So this is the GUI interface, which is rather friendly, gives us some functionality, and can be run even in a lightweight environment. So we know here we're on a particular TTY 1 that is indexed. Some OSs do it differently. Now we're on TTY 2. Say we pick TTY 5, authenticate, let's say, as a given user. And then this will give us the appropriate TTY. You need to shift TTYs, Control-Alt to break it, go back to another TTY or another user there. So it makes management much easier. See who's logged onto the system at a particular time, check the configuration, etc. Check the resources while this is running from another node, maybe XM top. It gives you a sense as to what the node is doing. Send the node to work, the utilization will rise, which is expected, and so on. So since we're done with this, let's just go ahead and exit and lock it out so that it doesn't leak any information unnecessarily. This gives you a full screen view that allows you to take over your whole screen if necessary. So you pop this, and then all of a sudden your whole screen becomes just that node. And then of course the screen becomes entirely as if it's your computer, as if you're on it. You can do things in it, maybe 6, reboot the system, etc. And then you'll see everything there. And of course, until you lose the session, if the VNC session drops at any particular point. The console is relatively good at keeping state. So as the resolutions, or at least adjusting to the shifts in the state associated with the resolution. So as it shifts, you'll see it shift accordingly. So if it takes the whole, this is 720/400, and if it flips to 640/480, then 800, Super VGA, then higher, it'll keep those perspectives for you with minimal interruption. So very straightforward, virtual machines, so on and so forth. You can view the manager to see the various nodes. You can create a new virtual host. That's rather straightforward as well. Specify an ISO image. You give it a name, let's say Ubuntu Guest 2 as your second node. Have it maybe install from an ISO image. Then you need to tell it which ISO image to use. Now this is all relative to the remote system, by the way. So depending on who you're connected as will determine where you're able to find ISO images, or you can browse your local system and find resources there as well. So let's say you look locally or remotely, and if you do it locally, then they'll pull it across the wire. Here it's roots, ISOs, and this local in this case is being the remote system. And we give it this ISO image, and that'll be it. You can specify the OS, let's say it's Linux, and it's 1204 as opposed to 1210, precise pangolin, forward, how much memory, CPUs, that can all be adjusted, of course, create disk image. This will create an image on the hard drive, but you can also select other storage if available, so you'd browse for it, and you'd check on the remote system where that storage is available. So let's say in the file system, in the dev tree, you look for where the storage under XenVol would appear, let's say Ubuntu Guest 1, or you can specify that it creates on an existing space, so create disk image on the computer's hard drive, but be sure that you have the space available. So let's see what we've got here. Let's kill this DFH, and we've only got 3.4 gigs available in this partition, so that's simply not enough to provision a whole node. However, we could set a partition to do so. So let's say we do a history grep lv create, for example. So this is for Ubuntu Guest 1. Let's copy this, paste it, changing it off to say 2, Guest 2. That'll now create a new node, if we'll, or a new volume that is, which we're calling a node, which is under XenVol 1, which is also 8 gigs, and just like that, we now have a dev tree entry with which we can reference for the creation of this new node. So you say select manage other, browse, look on the local, which is remote because we're redirecting X, and actually that's the ISO image. What we want is the dev tree entry, so file dev, it's going to be XenVol, which is down here somewhere. Ubuntu Guest 2 becomes the device location to which it should create its environment. So virtual networking, this can use NAT, or you can do a specify a shared device name, the bridge name. We don't want to do NAT because that entails, of course, routing through our primary interface. So the bridge is Xen bridge 0. And this is just the VIF configuration entry that you've seen before. And it will use 8 gigabytes of storage, a gig of memory, full virtualization as opposed to para virtualization, which is PV. So full virt is basically HVM. x86-64 is the ISO image. This is the MAC, but you can set a different MAC if you'd like, if it suits your configuration, or however you've got things documented. The ability to customize configuration before the installation, or just go with the basics. So now the virtual machine is now being created. Allocation of disk storage, unable to complete. Let's see what errors have come back. So here's the traceback, unable to complete. An error occurred, but the cause is unknown. So it shows CB wrapper. Let's see if anything here jumps out at us that makes any sense. Failed creation, connection self, so on and so forth. And it gives an error. Let's see if we're able to customize it, if this will allow us to make any changes. Sometimes there are errors, and this is why doing it, of course, through the shell is usually foolproof. But let's see if we can get a begin installation going at this point. So let's just double check processor. If not, we can always do it remotely, fire the node up, and then do it as we've already done. And that'll give us another node either way. So enable boot menu, disk 1, 8 gigabytes, should point to this. The NIC is using Xen bridge 0. That looks good. That should be available. Display VNC. And that'll use VNC there, address, password. I'll do it on the loopback adapter, although we usually want it to do it on all. And then the console, PTY. So let's see if it'll take, and begin installation. And it might throw an error, but that's fine. We can always do it on remote system. Unable to complete, domain not found. Now the domain not found, usually the create hasn't been executed. So let's do a cancel, and let's do an XM list on a remote system. So it doesn't see it. Now let's see if it's created the config file. It doesn't exist there as well. So the thing to do in this case is just copy the existing config file, Ubuntu guest 1 config to Ubuntu guest 2 config, make the changes and do it. It's usually the better way to do it. There are usually issues with the GUI. So this will become, instead of guest 1, and this can of course be scripted, guest 2. All this looks good. And instead of C, this becomes DC, or the original, so we'll C comment this and uncomment that. And the name is the other component that needs to be changed to make it unique. And then we should be able to XM create Ubuntu guest 2. That starts a domain, and now we should be able to connect to it. So let's see if we can do an XM list, XM VNC viewer 20, that's the ID that's assigned, and that'll pop up a window for us which will allow us to install this node rather quickly as well. So you will find some issues with the GUI, and you can go debugging, check online to see what the problems are, but my suggestion always is operate from the command line. It's just good to know that there are GUI tools that can help us out. So I seldom use the GUI tools because there are issues that prop up, whereas the majority of the work in this space happens with the shell-based tools. So as much as you can get done from the shell, do so. But if the GUI can help you out in certain areas, by all means use it, because it'll be useful. That's, if not, for at least to be able to visualize the settings associated with nodes. Now let's see what it's doing here. We drop connection because of a shift. Now it comes up, and then the rest is just as we've done before. It might as well be as easy to simply clone the configuration to have it going. But we'll just go through with this configuration since we're here, and it's rather quick. Again, cloning a configuration can be as simple as cloning the dev tree entry, the dev zenvol1 Ubuntu, or Ubu guest 1, that is. Let's just take a look at the volume name. So let's do an LV display. So if we could just simply clone Ubuntu guest 1 to a new name, such as Ubuntu guest 2, fire the node up, providing the other node is not up, change the IP related information, host name information, then within maybe a couple minutes, even less, we could have a new node up without having to enter this form field information. So let's say LCBT Ubu guest 2, fully qualified as usual, so we'll go forward with this. And LCBT user as usual. Again, it just precludes us from having to enter these form field data, but it's not such a big deal. And we'll tell it not to encrypt for now, just to save time. Time zone is correct. And this will just go through the installation. We're choosing Ubuntu because the ISO image is readily available. You could as easily install, say, CentOS or some other distribution, SUSE, Debian, which is one and the same with Ubuntu with respect to provisioning, etc. So it's just easier for us to go forward with Ubuntu because we have the ISO image. But pull the ISO image in for your distribution, and in no time you'll have an HVM. Remember, the HVM will support pretty much any x86, x86-64, or Intel, AMD compatible operating system. So you can install the typical Windows, Solaris, FreeBSD, all the BSD streams. Anything x86, 64 will work. So that's off to the races, and we've looked a little bit at Virt Manager. Perhaps as a separate task, we'll just say we provision new system, and that's going to be LCBT Ubu Guest 2, simply because, and we'll just say via CLI because of error in GUI, and that's not a problem. It's, again, very easy to do. Let's see if what the prompt here is. This is actually moving quickly. And again, now this is installing rather rapidly whilst the other node runs. So XMList shows the other node's available, and we should be able to ping it. So 75, 155. Currently, we'll maybe name this one 166. Let's see what it's doing. And 155, we'll probably have to connect to it. So let's see. It's not coming back. Try to hit 50, neither, so we'll double check that. And maybe from one of these other windows we'll do a VNC connection. So let's get that going in a separate shell. Now in this node here we can tell if there are any issues with VNC by quickly netstatting. So let's netstat and TLP grep. So 5900, 5901 as they do it shows QEMU DM or QEMU DM, however you want to call it. And then let's do a VNC viewer. LCBT Ubu VM1. The next instance will be 1, and that should pop up this node momentarily if it responds. Actually, 1 is this one. We're already connected. We want to connect to 0, the original one. So let's just see that this connects, and let's see what it's coming back with. It's taking a bit to connect. It should be a little bit faster than that. And it should be a lot faster than that. Let's do a netstat ANT, and let's grep 590. And here are the connections coming in. It shows established, so let's see what's happening. Maybe it's popped in the background and we just can't see it. So let's do install security updates automatically. Let's see what we've got here. And actually, this wants us to pick on this side. So rather than confuse it, let's just get this independent of that. Let's see if there are any other windows. And that's actually up. So we have 2 instances here. So that's the problem. So this is UbuGuest 1. And let's drop libvirt altogether. Virt Manager, that is. We no longer need that instance. Authenticate there or specify the password. And now we get the instance for the other one. So it's because Virt Manager had it. So 2 instances going, no problems there. We've yet to clone, as we've done with VirtualBox, but it's rather straightforward. And then there are also some other options, like the ability to create your operating system on files. So you'll have one file for the main file system, another for swap, and then those 2 can be easily transported. You can also transport volumes, LVM volumes, using LVM tools, and then just make the differentials or the changes. Let's see what's going on with our if config here. Let's try to send some packets out because we were unable to get to it earlier. And currently it's not communicating, so we'll see what's going on. And let's see our netstat rn, and that should see .1. And let's see what's happening back here. So that one's not communicating. Let's try to hit the host .105, and nothing here. So no packets are moving out of this one, just this instance. So we'll figure that out. Let's see what's happening back here. This is almost done. And we'll have to shift the configuration here as well so that it boots accordingly. Let's take a look at the XMList on the main server. So this shows the 2 resources. Let's see how much resources are free and an XM top. So we've got 4 gigs of memory free. And we've got the usage such that 20% and CPU seconds, or seconds that is 0.3, 88%. So this is using the bulk of it because of the installation. And memory-wise, percentage 12%, a gig, so that's not a big deal. We have ample memory, ample CPU currently available. So this is moving through. Let's tell it to do grub on the default device XVDA. That should be XVDA1. And remember, the creation with XMCreate does not automatically cause or allow the system to boot on the default hard drive. So that's something we'll have to update manually. So again, once the system's off, so XM list, it won't boot automatically. So you can kill it at this point. You can XM destroy 20. That's this one. It's going to kill that window. Modify the config file, Ubuntu guest 2. Set this to C, comment that, and then XM new Ubuntu guest 2.cfg. That should create it. Now XM list should show it. Then XM start Ubuntu guest 2. Now before we do, let's try to send some packets. Let's get back to this window. So we'll ping C3 192.168.75.155. Sometimes when you lose connections, it could be because the bridge is down, but I don't think that's the case in this case. So bridge control show. The bridge is definitely up. VIF 17, let's do an XM list. So 17 is bound to ETH0, no problems there. And then additionally, you may have issues with the IP address that's being used being redundant, or maybe even a shift in the bridge that's used for the configuration. So let's just make sure there's nothing funny with the bridge configuration, etc zen ubuntu guest 1.cfg. That would be specified in the VIF, or the specifier for the network. So there's nothing there that shows that it's using a different bridge, so that should not be a problem as well. So let's XM list, XM start Ubuntu guest 2, and then XM VNC viewer Ubuntu guest 2. Presumably it's on 18, and let's see if we SSH'd, and this didn't, so that one doesn't have the SSHX command, so let's do an XM list on this one, and then XM VNC viewer here, 21, that should kick it back here, and this is coming up. So it didn't write the last step because we killed the process, so that's normal. So it's actually not going to be able to boot. Let's do a restart. We actually didn't allow it to write the grub boot menu, so we'll do an XM destroy Ubuntu or 21, and that's not a problem. So that's because we stopped it prematurely. And we can actually XM delete a command we haven't looked at, Ubuntu guest 2, because unless we get in there and write grub to it manually, which we can, then it won't boot currently, so we'll just let that be. So again, not to segue off to installing another operating system, we just wanted to look briefly at the Virtual Manager GUI and some of the things we can do, and then back to provisioning more nodes. So we have two nodes, one doesn't boot, the other does. So let's move on to some other things.